Elizabeth Clan from Clan Maths. Today I've got an advanced higher maths mock paper. This is courtesy of Arcademaths on TikTok. Follow his stuff if you like this kind of content. Now I will tell you, he's got a paper 1 and a paper 2. I'm going to do a paper 1 right now. I will tell you that the first question or two is a little bit out there. I'm just saying. The rest of them, pretty good. The numbers work really well. It's just that the first one, the numbers come out a bit funky and a bit weird. It's hard to simplify them. So don't get put off by question 1 and just go from there. Question 2 onwards, it's pretty standard. It's quite a good little paper. I'll do this today, then hopefully tomorrow we'll get on to paper 2 or maybe later today if we're really lucky. Now, remember, Advanced Higher Maths, we've got our last minute live stream exam prep tomorrow at 7 p.m. That's Sunday the 11th of May. Members only, £4.99. Just click the members tab and join now. We're going through everything you need to make you confident for your exam on Monday. Claremont Maths is sponsored by Lecky, the educational publisher for Scotland. They offer viewers of this channel a massive 30% discount. Just use the discount code ClareLearnMaths at leckyscotland.co.uk. The practice question books go all the way from level 3 to advanced higher and include National 3, 4 and 5 apps as well, so you can get any book you need for your studies. These are an excellent resource with questions on every topic and contain work solutions so you can see how the marks are awarded. As you go through the book, the questions get increasingly difficult, so by the time you finish your book, you'll be ready for your exams. Usually £9.99, just use the discount code ClareLearnMaths to get 30% off that. Link down below. So let's look at part A. We're going to have to log both sides because there's an x in the power position. So just ln y equals ln 4 to the half x cubed plus 12x. And then we can take all of this down in front. So log y equals a half x cubed plus 12x times log 4. And then we can just implicitly differentiate both sides. So 1 over y, the y by dx, every time you see a y, you write the y by dx, equals all of this differentiated. Well, what is all of this differentiated? Well, that's just a constant on the end. So I can just leave that constant hanging out for the right and just differentiate inside the brackets. 3 halves x squared plus 12. Now we need to find the y by dx. So the y by dx is y times all of that. Now, if I wanted to, I think the SQ would tell you if you wanted it in terms of y in terms of x. I think we want it in terms of x. So our original y was 4 to the half x cubed plus 12x. So I'll put that back in. 4 to the half x cubed plus 12x times log 4 3 over 2x squared plus 12. Looks quite funky so far, but I think that's about as simple as it's going to get, really. Not really going to do much more with that, so I'm going down there. Okay, question B. Find f dash pi over 4 from this. So this is going to be the quotient rule. So f dash x to start with equals v times u dash minus u times v dash, which is minus 4x plus 8, all over minus 2x squared plus 8x, all squared. Now we could play around and try and simplify that, but I might as well just try and sub in my pi over 4 and see what we get now. So f dash pi over 4, and this is non-calculator, minus 2 pi over 4 squared plus 8 times pi over 4 cos pi over 4 minus sine pi over 4 times minus 4 pi over 4 plus 8 all over minus 2 pi over 4 squared plus 8 pi over 4s, and then all squared. Right, so I'll try and simplify that as best I can, but I'll be honest with you, with this question of simplification, there's not much to it. You kind of leave it quite messy. So just bear that in mind for this question. I'm not sure the SQA would give one that leaves it as messy as this, but let's try. What's cos pi over 4 and sine pi over 4 is what we first of all need to ask ourselves since we're on a non-calculator paper. So pi over 4 is 180 divided by 4, which is 45 degrees. So a 45-degree triangle, we've got 1, 1, root 2. So cos and sine of pi over 4 is 1 over root 2. So our f dash pi over 4 is equal to, well, take that minus 2 times by pi, and that'll be over 8. So that's minus pi squared over 4, because, so I'll take that minus 2 and I'll have pi squared. 4 fours is 16, but 2 over 16 is 1 over 8. So minus pi squared over 8 for the first term. 8 over 4 is 2, plus 2 pi then, all times by 1 over root 2, minus 1 over root 2 again, times minus 4 pi over 4 is just minus pi, plus 8, all divided by pi squared minus over 8 plus 2 pi all squared. So you could actually split this into two brackets if you want. If you think of this first term here, I'll just highlight this. You've got that, which is exactly the same as that squared. So that just cancels and gives you one of them. So you would get 1 over root 2 for that first term over minus pi squared over 8 plus 2 pi. And then the next term, you would get minus 1 over root 2 minus pi plus 8 over minus pi squared over 8 plus 2 pi all squared. Now, you could rationalize the denominator, I suppose, and have this is root 2 over 2 and that is root 2 over 2, but it doesn't really make it much simpler. You could kind of move the root 2 down to there and have that as 1 over root 2 times that. The idea being, I think we'll just leave that there and move on to question 2. SQA Advanced Higher Maths 2025 Mock Paper 1 question 2 says, sketch the graph of bar f of x, or the modulus of f of x, of course, given that f of x is x cubed minus 6x squared plus 9x, and the graph for f of x is that. And it's not giving us any turning points or anything on there, but hopefully we can do something with that. And then we'll have to find the nature of the x stationary points of f of x using the second derivative test. And if f of x is f of x odd, even, or neither, justify your answer. So hopefully this will be a nicer question to look into now. Now I'm going to assume, since that this was only 1 mark, that Arcademaths made this, that they're not actually bothered about what these are. So I'm just going to draw the modulus function first of all without it. Although it makes me a little bit uneasy. I think in the exam you would have to have where the main points are. But the idea with a modulus function is that negatives become positives. So that just moves up to there. I mean, everything else is already above. So it stays exactly the same, whatever it was before. So it's exactly the same curve, except that's moved up. That's obviously 0, 0. I wonder if we can find the turning points. We're going to do that later. So we'll just leave that there. And we'll move on to part B. Find the nature of the x stationary points of f of x using the second derivative. Okay, f dash x is 3x squared minus 12x plus 9. Second derivative is 6x minus 12. So I need to know what the stationary points are. So stationary points are when f dash x equals 0. So 3x squared minus 12x plus 9 equals 0. 3x squared minus 4x plus 3 equals 0. So 3, double bracket, x and x, minus 3, minus 1. You've got stationary points at x equal to 1 and x equal to 3. So looking at their nature, f double dash 1 is 6x minus 12. So 6 minus 12, which is minus 6, which is negative, and therefore it is a x equal 1 is a max turning point. Negative means max, positive means min. And then similarly, f double dash of 3, well, it's 6x minus 12, so it's 18, minus 12, which is 6, therefore x equals 3 is a min turning point, and we're done there. Question C, is f of x odd, even, or neither? Justify your answer. You can maybe try and do it by looking at the graph. The graph's not got any things on it. We've now actually got on the graph that that's along 1 something and that's along 3 something. So we could look to see if there was like a reflection in the wax or anything. But since we've got the equation, I actually will use the equation for this. F of x is x cubed minus 6x squared plus 9x. So for part C, f of x is x cubed minus 6x squared plus 9x. And all you need to examine is f of minus x. So what is f of minus x? Well, that's just subbing minus x in. So that's minus x cubed. Minus x squared is just still x squared. So that is just minus 6x and then minus 9x. Now, is f of minus x equal to f of x? No, it's not. And therefore, we can say that it's not even, because it has to be the case that if f of minus x equals f of x, it's even. So it's not even. And then does f of minus x equal minus f of x? That's the term for odd. Well, let's just check. If I put a minus here, I get minus. That's okay. Minus here, oh no, it's failing again. So it's not odd. So now, in other words, if it's not odd and it's not even, it's neither. And we're done there. Next grade Advanced Higher Maths 2025 mock paper 1 question 3. Show that this is in partial fractions. Do partial fractions. So we say that 5x squared plus 7x plus 4 over x plus 1, x squared plus 2x plus 5, and I can't factorize x squared plus 2x plus 5, equals a over x plus 1 plus, well, since I can't factorize that, bx plus c over x squared plus 2x plus 5. So now that implies we've got a x squared plus 2x plus 5 plus bx plus c x plus 1 equals 5x squared plus 7x plus 4. So let's see what happens when x equals minus 1 to get rid of this term here, the second term. That'll give me minus 1 squared, which is 1. And then 1 minus 2 is minus 1 plus 5 is 4. So in other words, 4a equals 5 minus 7, which is minus 2 plus 4 is 2, and therefore a is a half. Okay, let's try x equal to 0 now. So that will give me 0, 0, 5 times a half, so 5 halves. 0 here, so just c times 1 equals 0, 0, 4. So that means that I can say that c is 4 minus 5 halves. Well, 4 is 8 halves, 8 minus 5 is 3 halves. And there's a c. And then trying any other number, let's say x equal to 1. 1 plus 2 is 3, plus 5 is 8, times a half is 4. And then we've got 1b. I'll write this out actually. So b plus c, x plus 1 is 2, equals the right hand side 5, 6, 7, 12, 13, 15, 16. Simplifying that out, we've got 4 plus 2b plus 3 equals 16. So 2b plus 7 equals 16. So 2b equals 9. So b is 9 over 2. So now to write it out, a over x plus 1, a was a half, so it's a half over x plus 1 plus bx plus c all over x squared plus 2x plus 5. Now you wouldn't normally leave it like that, so let's just make that neater. That equals 1 over 2x plus 1 plus, well, that's just 9x plus 3 over 2, remember, here. So that 2 can go down. So 9x plus 3 over 2, x squared plus 2x plus 5. And we're done there. SQA Advanced Maths 2025, mock paper 1, question 4. Gaussian elimination. So I've got 2, 1, minus 1, 1, minus 3, minus 1, 2, and minus 4, minus 2, 1, 2, minus 1. And the game with Gaussian elimination is to get zeros in this position here. So I'll do row 2 becomes, well, I'm going to have to times it by 2 to get 6, and then add 3 row 1. And then row 3, I can just do row 3 becomes row 3 plus row 1. So 2, 1, minus 1, 1, minus 6, plus 6 is 0. Then we've got minus 2 plus 3, 3 minus 2 is 1. And then we've got 2 2s is 4, and then 3 1s is 3, 4 minus 3 is 1, and then 2 4s is 8, 3 1s is 3, minus 8 add 3 is minus 5. And then we've got 0, 2, 1, and 0. And now we need to get a 0 in this position. And we're going to use these two rows. So row 3 becomes row 3 minus 2 row 2. So then let's go from there, right? So we've got 2, 1, minus 1, 1, 0, 1, 1, minus 5, and 0. 2 minus 2 is 0, 1 minus 2 is minus 1, and 0 minus 10, well, it's minus 10, so it's plus 10, so it's 10. Hope we get the idea. And now we can solve. So we've got minus z equals 10, ergo z equals minus 10. Job done there. And then we can sub in again. We've got y plus z is minus 5. So we've got y minus 10 is minus 5. So y is minus 5 plus 10, which is 5. Then we can sub in again. 2x plus y minus z is 1. 2x plus y minus z is 1. 2x plus 5 minus 10 is 10 equals 1. So 2x equals 1 minus 15, which is minus 14. So x is minus 7. And we're done there. SQA Advanced Higher Maths 2025 Mock Paper 1, Question 5. Given that A is 2104, B is 38 minus 12, C is 1003, I'm sure you can read this yourself, D equals 2A plus B transpose C, sometimes a little dash for that in your exam, minus 2I, where I is the 2 by 2 identity matrix, of course. Find the matrix D. And then part B, E is A plus 3I, obtain a similar expression for E to the 5. What a nice question this actually for a little bit of revision. So D is 2A, 22104, plus B transpose, which means you change the rows and the columns, okay? So 38 becomes 38 down the way, and minus 12 becomes minus 12 down the way, times C, which is 1003. And then it wants us to take away 2 times the identity matrix. So it's really testing this question that you understand what transpose and identities are, and you can times matrices together. Let's hope this works out. 2 2s is 4, 2 1s is 2, that's 0 and that is 8. Now, times and matrices, just a reminder on this then, you go along and down, get your first one. And along and down, get your next one. Along and down, get your next one. Along and down, get your next one. I feel like I'm on TikTok right now and someone's stealing money. You seen that trend? The guy goes up to the person with a phone and it goes, ding! You gotta steal your money. This is not going to be part of the video. Okay, so let's do this. What was I saying? What bit of it? 3 1s is 3 minus nothing, that's 3. That's 0 minus 3. that is 8 minus 0, which is 8, and that's 0 and 6. Hopefully that wasn't too fast for you. And then you've got minus, well, just 2, 0, 0, 2. I'll get the minus outside. Right, so adding and taking away. One matrix. We've got 4, 5, 6, 7. 7 minus 2 is 5. We've got 2 minus 3 is minus 1, and then 0. We've got 0, 8. And then we've got 8, 14. Minus 2 is 12. And hopefully we're done there. Part B says E equals A plus 3I. Find E to the power of 5. And it's a similar expression, so I'm thinking it's wanting this in terms of matrices like that instead of writing out a matrix, because I think that would be too much anyway. So we're wanting E to the power of 5. Well, what am I going to use to work out a fifth power? Binomial theorem, of course. And I can use Pascal. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1. Adding up 4, 6, 4, 1. Wanting to get to the fifth one, so 1, 5, 10, 10, 5, and 1, and that's Pascal's triangle. So we've got A plus 3I to the power of 5. So expanding that, we've got A to the power of 5 plus 5, A4, and then the next term comes in, 3I, plus 10, take 1 away for A cubed, 3I squared, plus 10, take 1 away, 3I cubed, plus 5, take 1 away, then it goes up by 1, so that's to the power of 4, and then finally, you've just got your 3I left, all to the power of 5. Now remember, I is the identity matrix, okay, so bear that in mind when we try and simplify this. So that's AI, A5. Now 5 times 3 is obviously 15. A to the 4 times I, well, I is just like 1. So that's just like, well, A. Anything times 1 is the same thing. So that's A to the 4. Nice. So then we've got 3 3s is 9. 9 10s is 90. So we've got 90. A cubed times I squared. Well, who cares about I squared? That's just the same as times it by 1 times it by 1. So that's just A cubed. And then we've got 10A squared. 3 cubed. Well, 3 cubed is 27 times 10 is 270, of course. So that's just 270A squared. Again, I cubed. Well, I cubed is just, well, 1. So there you go there. And then the next one, 3 to the power of 4, getting a little bit trickier. 3 3 is 9 times 3 is 27 times 3 is 81. And you do 81 times 5, which is 405. So we get 405A. Let's hope my maths did not fail me there. And then all the i's just disappear because it's just times it by 1. And then 3 to the power of 5. Oh gosh. 3 3 is 9 times 3 is 27 times 3 is 81. Times 3 is 3 1s is 3, 3 8s is 24, 243. However, I will have to write I here because there's no matrix on the end. So it's just a number times I, so the I is still there. I can get rid of that I if I'm times it by a matrix. So I to the power of 5 is I, because I times I times I times I times I is I. So it's I on the end. And we're done there. SQA Advanced Higher Maths 2025 Mock Paper 1 Question 6. Z equals 1 minus I. Express Z bar in polar form. Well, what is Z bar? Z bar is the complex conjugate of Z. So that means that I need to write Z bar is simply 1 plus I. You just switch the sign on the second thing. Now, it wasn't in polar form. That is cos theta plus I sine theta, if you remember. So I need to then find the modulus and the argument of this thing. So what's the size of it? The size of it is just Pythagoras. Still doing Pythagoras Advanced Higher Maths. How fun is that? 1 squared plus 1 squared square rooted is root 2. Hopefully you can do that in your head. And then what about our argument? Well, tan theta equals the imaginary part, which is 1, over the real part, which is 1. Which means that theta is the inverse tan of 1. Well, the inverse tan of 1 is 45 degrees, which is pi over 4, because it's the exact value. And therefore, Z bar is equal to root 2 cos theta plus I sine theta, cos pi over 4, plus I sine pi over 4. And we're done there. It's been Clear on Maths. And today we've done Advanced Higher Maths 2025 Mock Paper 1 courtesy of Arcademaths. Hopefully you like this content. Remember, we've got our live stream still on Sunday the 11th of May at 7 p.m. Just like this, share this, do whatever you want with it, but have fun, take care, stay safe, and goodbye.